Hi everyone, welcome to Calc Lesson number 67. Today we are going to look at both integration and differentiation of exponential functions. So we're going to go through a couple of different supplemental problems for each to kind of finish up these topics. So before we get started, let's recall our differentiation rules for the natural exponential function e to the x. These are on your formula page, but if you don't have that or you don't have your notes from the other day handy, you might just want to jot these down so you have them. The first is your basic definition that the derivative of e to the x is just e to the x. And then the second is if you have more than x as your exponent, so if you're taking the derivative of e to the u, that can be e to the u times du dx, or the way I like to think of it, e to the u times u prime. So make sure you have these handy for the next couple of examples. So example 1 is kind of like a little warm-up problem, going to get our brains back into that differentiation mode. Here we want to take the derivative of e to the negative x over 2. Obviously our exponent is more than just x, so we want to think about the definition from the previous slide, that the derivative of e to the u would be e to the u times u prime. So we need to identify a u. In this case, I'm going to choose my entire exponent, negative x over 2. Whoops. And because I'm going to be taking the derivative, I'm actually going to think about writing this as negative 1/2 x. That just makes it a little bit easier for me to find u prime. Using my basic power rule, u prime is just negative 1/2. Now, following my definition here, the derivative d dx of e to the negative x over 2 is going to be equal to e to the u times u prime. So e to my u, which is that negative 1/2 x, or negative x over 2, times u prime, which is negative 1/2. So I can write my final derivative as negative e to the negative x over 2 over 2. And I'm actually going to leave that negative exponent is going to be okay for now. Okay, now that our brains are nice and warmed up, we're going to look at a little bit more of a complex example. Here we want to find the equation of the line tangent to the graph of y equals x squared times e to the negative x at the point 1 e to the negative 1. So we're looking for the equation of the tangent line to our functions. I'm just going to highlight so we have it outlined here. X squared times e to the negative x, and then they're giving us this point 1 times e to the negative 1. And again, we're looking for the equation of the tangent line. So our ultimate final answer is going to be in a y equals mx plus b form. Remember, when we start these equations, when we start these problems, we have to start by finding the slope of the tangent line. And remember, the slope of the tangent line comes from the derivative. So let's start by taking the derivative of our function. So y prime is equal to, now you guessed it, we have x squared times e to the negative x, which means we actually have to use a product rule. So as we go through, I'm going to write out all of my steps. So my product rule is my first function, x squared, times the derivative of my second function. So I'm going to write this in another color so we don't forget about it. D dx of my second function, e to the negative x, plus my second function, e to the negative x, times the derivative, d dx, of my first function, x squared. So this is my product rule, and remember, I like to write out my ddx steps, that now my product rule, I'm done thinking about that, and I can just fill in those two derivatives. So to find the derivative, d dx of e to the negative x, I'm actually going to pop to the side. So let's keep it in purple, shall we? D dx of e to the negative x, well, this is what we learned in our previous differentiation class. Remember, the derivative of e to the u is e to the u times u prime. So let's let our u equal negative x, which makes u prime equal negative 1. So this derivative would be e to the u, which is negative x, times negative 1, or just negative e to the negative x. So there's the work for that derivative, and we can go ahead and fill that in. So our derivative is y prime equals x squared times negative e to the negative x plus e to the negative x, and now taking the derivative of x squared, hopefully we remember using the power rule, that's just going to turn into 2x. So now we've done all of our differentiating. Let's just simplify this really quickly. Y prime is equal to negative x squared times e to the negative x plus 2x times e to the negative x. And we could simplify further. I'm actually just going to leave it like that for now, because since we're finding the equation of the line tangent to the graph, we're going to end up plugging in. So now that we have our derivative, our next step is going to be to evaluate the derivative at the x value that they gave us. So let's look at y prime evaluated at 1. Gives us negative 1 squared times e to the negative 1 plus 2 times 1 times e to the negative 1. Okay, so kind of messy, but at least it's just 1s. So this becomes negative 1 squared is just negative e to the negative 1 plus 2e to the negative 1. So if we have negative 1e to the negative 1 and a positive 2e to the negative 1, that's just going to be equal to a positive 1e to the negative 1. So our derivative evaluated at 1 is equal to e to the negative 1. So that's actually going to be our slope. So we're still not finished, because our ultimate goal, remember, was to find a line in that y equals mx plus b format. So we want to go ahead and plug in our x and our y and our m to solve for b. So plugging into y equals mx plus b, our y is e to the negative 1 equals our m is also e to the negative 1 times our x is 1 plus b. Gives us e to the negative 1 equals e to the negative 1 plus b. If we subtract e to the negative 1 on both sides, we are left with 0 equals b. So our b value is going to be 0, which means our equation of our line tangent to the graph, plugging in just our m and our b, is y equals e to the negative 1 times x plus 0, or we don't even have to write that. So this is going to be our final answer equation, y equals e to the negative 1 times x. So kind of a longer process there. Go ahead and look through the steps. Remember, you want to start by finding your derivative, plugging in your x value to find your slope, and then plugging in your x and your y to find your b value, and then ultimately giving your answer as an equation of a line. Now we're going to switch over to integration. So just a quick review of some important integration formulas. So I have on here your exponential function integration, but also the integration formulas from our natural log unit, because as you guys know, e to the x and the natural log are very closely related. So just make sure you have these for handy throughout the next couple of examples and then on tonight's homework. Okay, so let's start by integrating 2e to the x minus 2e to the negative x over the quantity e to the x plus e to the negative x squared. Now this one looks crazy at first, and the first thing I notice is that my numerator and my denominator look very similar, and I also have a 2 in both of my terms in the numerator. So I'm going to start by actually factoring that 2 out just to see how similar they actually are. So let's rewrite this as the integral factoring out my 2. This becomes e to the x minus e to the negative x over the quantity e to the x plus e to the negative x squared. So the only difference I'm really noticing there is the sign in the middle, but they are in fact different. Now, in order to integrate this, I would either need to simplify or rewrite, and we rewrote as best as we could. So when I have a rational function, or when I have x's in my numerator and my denominator, I need to use some kind of u substitution, and typically we choose the inside of our composite function in the denominator. So let's go ahead and see what happens if we choose our u as the inside of our composite function in the denominator. So let's let u equal e to the x plus e to the negative x. Now we're doing basic u substitution here, just like we did all throughout the previous chapters. So once we take u, we want to find du. Taking the derivative of e to the x, we get e to the x. Taking the derivative of e to negative x, you might start to remember it, or you might have to go back and use a u for that situation as well. Bringing down your negative, you get negative e to the negative x. And then this whole quantity times dx. So remember, there would be a dx attached to each term. We're technically factoring it out. That leaves dx equal to du over e to the x minus e to the negative x. So classic u substitution. Let's go ahead and replace those u and du into our equation and see what we have left. So here we have the integral of 2 times e to the x minus e to the negative x over, we can replace with u squared, and then we can replace our dx with du over the quantity e to the x minus e to the negative x. So making those substitutions, hopefully you're noticing that now the e to the x minus e to the negative x match in our numerator and denominator, so they cancel out. We still have that 2, but that's okay. It's just a constant multiple. It can get pulled to the front. So we have 2 times the integral. Now what we have left over is u squared in the denominator. Remember, when you have an exponent like that, you want to write it as a negative exponent. So let's write this as u to the negative 2 du. And now we can just go ahead and use our basic power rule. So we're going to keep our 2 on the outside. We're going to raise u to the 1 higher power, and 1 higher than negative 2 is negative 1, and divide by that same power. Let's simplify this to be negative 2 over u, and then of course a plus c. And our final step is going to be to replace our u with what we substituted in the beginning. So this integral is going to be equal to negative 2 over e to the x plus e to the negative x. And then because this is an indefinite integral, we need to keep that plus c. So a basic u substitution problem that started out looking crazy, we had to simplify, use our basic u substitution, and we ended up with our final answer. Okay, just a few more problems today. Number 4 is the integral of e to the 4x minus e to the 2x plus 1 all over e to the x dx. At first glance, this looks really intimidating, but hopefully you notice that we have just one term in the denominator, which means we can actually split this up. So I'm going to write out all of my steps. So let's rewrite by splitting up. I'm going to first split this as e to the 4x over e to the x minus e to the 2x over e to the x plus 1 over e to the x dx. Now, because in our first two terms we have the same base, we can use our properties of exponents to simplify. So we can subtract our exponents 4x and x, and we can subtract these two exponents as well. So in an additional rewrite step, I'm going to simplify, and I'm going to split into 3 separate integrals. So I'm going to write this as the integral of e to the 4x minus x just gives me 3x dx minus the integral of e to the 2x over e to the x simplifies just to be e to the x plus, and for my final term, instead of writing 1 over x, I'm going to make that a negative exponent, so this becomes e to the negative x. Whoops, I forgot my dx. Sorry about that. Okay, so now that I've split it, I have 3 separate integrals. You don't have to write it out like that, but it just helps my brain to see each piece individually. So now I'm going to go through, and I'm first going to integrate e to the 3x dx. Now, remember, I need to represent this as e to the u, so let's let u equal 3x. That makes du equal 3 dx. So dx equals du over 3, which means I'm really integrating e to the u times du over 3, or 1/3 the integral of e to the u du, which just leaves me with, 1/3 e to the u, and I'm going to replace my u with my 3x. So my first piece becomes 1/3 e to the 3x. My second portion, the integral of e to the x, is one of our basic definitions, is just e to the x. Not too much work to do for that one. And then my final piece, e to the negative x, again, I'm going to need to use a u, so let's let u equal negative x. That makes du equal -1 times dx, so dx equals negative du. Integrating e to the u times negative du means I'm really integrating negative, oops, that's fine, bring our negative out, e to the u du simplifies to be negative e to the negative x. So now we can go ahead and replace each integral with what we found. So the integral of e to the 3x is 1/3 e to the 3x. Then we're going to subtract the integral of e to the x, which is e to the x. And then we're going to add the negative, so we'll subtract e to the negative x. And because this is an indefinite integral, we're going to finish with a plus c. And again, it is okay to leave those negative exponents for us for now. So go ahead, take a look over, ask any questions that you have on each individual piece or on the problem as a whole. Okay, for our last example of the day, example number 5, we are going to look at some definite integration. So we're going to integrate the way that we have been throughout this video and throughout this chapter, but then we're going to also account for changing over the 0 and the 1 to be in terms of u as well. So looking at our integral from 0 to 1 of x times e to the negative 3x squared dx, we need to use u substitution so that we either have a power rule or e to the u. So it's best practice to choose our exponent here as our u value, at least at first, to try and see what happens. So let's let our u equal negative 3x squared. That means that our du would be negative 6x dx. So dx would just be du over negative 6x. If we start replacing, we have the integral of x times e to the u times du over negative 6x. So it's clear that our x's are going to cancel. So this u is going to work. Now we need to also account for our bounds. So when x is 1, u is negative 3 times 1 squared, which is just negative 3. So we can replace our 1 with a negative 3. When x is 0, u is equal to negative 3 times 0 squared, which is just equal to 0. So we can replace our 0 with a 0 or just leave our 0. So now we've changed our problem completely into terms of u, and we don't have to switch it back into x in the end. So now we are integrating. I'm going to pull my negative 1/6 out to the front, and we have e to the u du. So we keep our negative 1/6. The antiderivative of e to the u is just e to the u, and now we're going to evaluate from 0 to negative 3. Let's keep our negative 1/6 on the outside and plug in our e to the negative 3 minus e to the 0. Now anything to the 0th power, hopefully you know, is just 1. So this becomes negative 1/6 times e to the negative 3rd minus 1. And that's going to be a totally fine answer. If you'd prefer to give it as a decimal, you could give us 0.158, and that would be acceptable as well. Great job with these supplemental problems for integrating and differentiating the natural exponential function. Homework 67 is a handout that is probably posted for you in class notebook. If you have any questions, you can go ahead and ask your teacher.